In Chapter 2, we started looking at functions, and I suggested that you should read the section in the text that talks about functions in the real world and how to work with function notation. So those are two important sections you should read in the text. And then the definition of a function is that it's a rule that assigns to each element x in a set A exactly one element called f of x in the set B. So these different terms for functions are some things that you should know: the value of f at x, the image of x under f. The domain of f is the set A that contains the x's, and the range of f is the set of all f of x's whenever x is in A. So here's an f of x, and if that x is in the set A, then f of x is in the range. X is sometimes called the independent variable, and f of x, or y, is the dependent variable because its value depends on the value of x. So we think of x as being an input and as f of x as being an output, and as the function f is the thing that converts the input to an output. Another way of thinking of a function is by the use of a so-called arrow diagram, and so that's what this is. This is an arrow diagram of a function, and it shows the sets A and B as little circle-type bean-shaped things, and then the elements of A are x and A and some random arbitrary value, and then f of x is here in B, f of A is here in B, and f of this point is that point in B. So that's the arrow diagram. If you want to express in words this function h of x right here, that would be the function that squares the input and then adds 2. This function f of x here would be the function that subtracts 1 and then takes the square root. Evaluating a function is just simply taking the given value for x and substituting it into the formula for f of x. So for example, f of negative 3 in this case would be negative 3 in parentheses squared minus 6. Negative 3 squared is 9, and 9 minus 6 is 3. So f of negative 3 is 3. So you should be able to do f of 3, f of 0, that's the y-intercept there, and f of 1/2. For the domain of a function, it's just the set of values that the variable is allowed to equal that give you a defined value for f of x. So there is no restriction here. Any real number x can be multiplied by 2, so the domain of this function is all real numbers. And again, to evaluate a function at a value, you simply substitute the value. Here you would substitute 1 where x is. Here you would substitute negative 2. Here you would substitute 1/2. And here you would just substitute the letter a. So f of a will just be 2a plus 1. 2a plus 1. And then here, f of the negative of a will be negative 2a plus 1. And then f of a minus 1 just means substitute a minus 1 wherever x is. Well, let's go back and remember what the function is here. The function is f of x equals 2x plus 1. So the function f of x is the function 2x plus 1. So f of a minus 1 simply means to substitute a minus 1 for x. So we'll get 2 times a minus 1 plus 1. And now by the distributive property, we can recalculate this as 2a minus 2 plus 1, and finally simplify to 2a minus 1. And so that's f of a minus 1. Okay, so we also want to study these so-called piecewise functions. A piecewise function, remember, is a function where the domain is split into pieces, and the piece of the domain you're on determines which piece of the function you're on. So for x values less than 0, our function is defined as x squared. And for x values greater than or equal to 0, our function is defined as x plus 1. So if we want to evaluate f of negative 2, since negative 2 is less than 0, we use this piece of the domain, x is less than 0, and so therefore f of negative 2 is equal to negative 2 squared, which is 4. Again, for f of negative 1, since negative 1 is less than 0, we calculate f of negative 1 as negative 1 squared and get 1. Now for f of 0, that's clearly equal to 0, so now we're going to use the second piece of the domain, x is greater than or equal to 0, so f of 0 will use the function defined as x plus 1, so that's going to be 0 plus 1, which is 1. And f of 1, again, we will use the piece of the function where x is greater than or equal to 0, and so f of 1 will be 1 plus 1, which is 2. Okay, so you can do f of 2. Okay, so next we see that we can evaluate functions in even more complicated ways. Here is f of x equals x squared plus 1. We want f of x plus 2. And so that means substitute x plus 2 into this function wherever you see the variable. And so f of x plus 2 will be x plus 2 squared plus 1. And x plus 2 squared is x squared plus 4x plus 4. Then we have plus 1, and we can simplify to x squared plus 4x plus 5. I'll let you do f of x plus 2, so that just means add 2 to f of x. So I'll let you do that part. We worked on this problem, Torricelli's law, in class. I'm not going to redo that one here. We did a lot of work on that one in class. For finding the domain and the range of these functions, here the domain is going to be, for this function, all the x's that are not equal to 3. So all real numbers except 3. So x cannot equal 3. But x can be any other real number, because when x is 3, the denominator is 0. Now for the range, 1 over x minus 3 is always, the range is all, well, we could talk about the range. It's easier to get the range if you look at the graph. Well, let's talk about that another time. For f of x equals the square root of x minus 5, since x minus 5 is inside of a square root, we have to have that x minus 5 is greater than or equal to 0, because you can only take square root of numbers that are not negative. Therefore, x must be greater than or equal to 5, and that's the domain. The domain instead of all real numbers greater than or equal to 5. The range is all positive numbers, because the square root of x minus 5 is always positive. I guess for this function, f of x equals 1 over x minus 3, the range would be all real numbers except 0, because that's the only value that 1 over x minus 3 will never be, because the only way that a fraction or a rational expression can equal 0 is if the numerator is 0, but we see that this function has a numerator of 1, which is never 0. So the range there is all numbers except 0.